We're going to look at a little bit more with particle motion, specifically looking at net and total distance. So this graph given here is a graph of velocity in meters per second of a particle, again, moving along the x-axis. So we've got right to left motion. So at what value of t does the particle have no acceleration on the interval 0 to 10? Justify your answer. So acceleration is the derivative of velocity. So no acceleration means no derivative, means not differentiable. So that occurs at these cusps. So we're going to say that a of t is undefined when the velocity function is not differentiable. Since v of t has a cusp at t equals 1, 3, 6, and 8 seconds, there is no acceleration. Remember, that's different than 0 for acceleration. No acceleration is that it's the velocity function is not differentiable. Okay, express the acceleration a of t as a piecewise defined function on the interval 0 to 10. We can do this because these are all line segments, so we know that their rate of change is kind of constant. I know the derivative is the same here at every point along that curve because it's a straight line. So what we're going to say is we're going to say the acceleration on the interval 0 to 1 the derivative is whatever that slope is. So it's up 3 and right 1, so it's 3. And we don't include the endpoints because remember there is no derivative at 1. Okay, and they're asking for the open interval 0 to 10, so we don't include 0, and we can't include 1 because the function's not differentiable at 1. Now we're going to do from 1 to 3. And the slope of that line looks like down 3 over 1. So it looks like it's negative 3. Then we're going to do from 3 to 6. That slope is 0. Then we're going to go from 6 to 8. That slope looks like we're going to go up 3 and over 1. And then the last one is from 8 to 10. And that looks like we're going to go down 3 and right 2. So there's our acceleration function as a piecewise function. For what values of t is the particle moving to the right, to the left? Justify your answer. The particle is moving to the right on the intervals when the acceleration, or sorry, when the velocity is positive. So we'll say when v of t is positive, which occurs on, let's see, 0 to 2. And then again, it's positive from 7 to 10. The particle is moving to the left. When the velocity is negative. which occurs on the interval 2 to 7. Find the average acceleration of the particle on the interval 1 to 8. Show your work. So now we're looking for the average from 1, which is up here, to 8, which is right there. So the slope of that line is going to be 0. But let's do it out. So the average acceleration, because remember, acceleration is the slope of velocity. So we're doing the average slope, or average acceleration. So we got to calculate these numbers. So V sub 1 is 3. V of 1 is 3. And then V of 8 is also 3 over 1 minus 8. So we're getting 0 over negative 7. So we're getting 0. And this was, what was this graph? In meters per second. Meters per second. So now we're talking about the acceleration because it's the derivative. So it's meters per second squared. On what interval of time is the particle speeding up or slowing down? Explain your reasoning. Okay, so we're going to say that it's speeding up when the acceleration, the sign of the acceleration matches the sign of the velocity. So that would occur when the velocity is above the axis, means it's positive and it's going up. So this is where it would be speeding up. This is where it would be speeding up as well, because both velocity and acceleration are positive. That means that the y value here is positive, meaning that's velocity, and it's increasing, which makes the derivative positive, which is acceleration. It would be slowing down wherever the graph is above the x-axis but going downward. So that's there and there. Those are slowing down segments. Also speeding up for below would be when it's below the axis and decreasing, because this would be a negative y value, which is a negative velocity. And since the function's decreasing, that means its derivative is negative, which is acceleration. It would be slowing down on this blue segment here, because the velocity is negative, yet the acceleration, the derivative, is positive. So those are the segments where it's speeding up and slowing down. It's not speeding up or slowing down here because the velocity is 0. The acceleration is 0. The velocity stays constant. So I shouldn't do that in green. So it's doing neither right there. So even though that velocity is negative there, the acceleration is 0. So it's not speeding up or slowing down. All right, so we're going to say the particle is speeding up when the velocity and acceleration have the same signs. Whoops. Hold on a second. Technical difficulty. Hang in there. Okay. When they have the same signs, this occurs on the interval um, 0 to 1, and then 2 to 3, and then 7 to 8. This slowing down, so we'll say the particle is slowing down when v of t and a of t are opposite signs. This occurs on the interval, whoops, not a period. Those were those blue ones. 1 to 2 and 6 to 7, 8 to 10. 1, 2, 6, 7, 8, 10. So 1 to 2, union 6 to 7, union 8 to 10. All right. So let's talk now about net distance versus total distance. So net distance would be the distance that an object travels, like where it, from the difference from where it started to where it ends up. It doesn't matter if it backtracks at all. So if we picture this particle moving back and forth on the x-axis left and right, it's just where it ends up. So let's say a particle started here, moves this way, say 5 units, comes back, say 3 units, and then moves forward another 5 units. The net distance would be 7, because it would be this 5 forward, then plus this extra 2. That's the net distance. The total distance would be the 5 plus the 3 is 8 plus another 5, which would be 13. All right, so that's the difference between net distance and total distance. So what we're going to say is net distance is the distance from where the object begins and where it ends. Total distance would be the sum of all the distances moved in any direction. If a particle is moving in the same direction the entire amount of time, what can be said about the net distance and the total distance? They would be equal. All right, so how are we going to find the net distance a particle travels on an interval? So we'll say on the interval I hate when it starts skipping like this. On the closed interval A to B, the net distance an object travels is the absolute value, because we're talking about distance here, so we're not going to deal with direction, is the absolute value of PA minus P of B, where P of T is the position function. To find the total distance a particle travels, a little bit trickier. So, and by the way, this represents starting position minus ending position, and then the absolute value, because we're talking about distance. We don't care about direction. Let's say provided the object, we're going to put 2 parts on this. Provided the object moves the same direction on the interval, then we know that the total distance is equal to the net distance, right? So we'll say the total distance will be that same formula. The position where it starts minus the position where it ends up, and the absolute value of that. But, so our part 2, if the object changes directions at, say, some time C on the interval AB, then total distance is equal to the absolute value of where the position where it starts all the way up to the position where it changes direction, the absolute value of that, then plus the absolute value. Now we're going to do the total distance from that spot where it changed position, changed direction, that position, minus the final position where it ends up. And of course, if there were more times it changed direction, this would just add more segments in there that we have to add to it. All right, so let's do a couple examples of this. The position of a particle is given by this function. So now we have the position function, not the velocity function. And this is in centimeters. Find the net and total distance the particle travels from 1.5 seconds to 4 seconds. So we're going to do this as a calculator active question. So we know that the net distance is going to be equal to the position at the start minus the position where it ends. And that's going to be approximately exactly that. So that's a calculated question. Now we're going to see we want to find the total distance traveled. So we've got to find any spots where the particle changes direction. That would be anywhere where the velocity changes from negative to positive or positive to negative. That means it all goes back to a derivative, a function and its derivative. When do we know velocity goes from positive to negative? It's when the derivative is equal to 0 is a possible spot. So we've got to do our derivative here. So our derivative of p, which is really the velocity function, equals 6t squared minus 12t plus 8. And now we want to do a sign analysis on this derivative and see where it changes direction. It's a well, I'm going to do this as a calculator active question. I would say it would most likely be. So you could put the derivative in your calculator, look at the graph, and see where the derivative switches from positive to negative or negative to positive, and that t value, that would be a spot where it changes direction, and we have to calculate the net distance on all those little segments and add them up. I'm going to do this one by hand and see if we can get there. Or actually, no, this one's not going to factor. So, but what I'm doing is, if I'm doing a sign analysis, I'm trying to factor it. Well, let's just go through it and see what happens. So I could factor out a 2, it looks like. And then I'm trying to find a number that multiplies to 12 but adds to negative 6. And that would be what? 5 and 1, 4 and 2. I can't do it, right? So this doesn't factor. So then what I would do is the quadratic on that. And I'm going to just check the determinant part, b squared minus 4ac first, and see if that's even possible. If that's a complex number, then I know there's no solutions. So let's take a look. B squared is 36 minus 4. A is 3. C is 4. So I've got the square root of 36 minus 16 times 3 is going to be bigger than 36. So this will be the square root of a negative, which means that's a complex number, which means there are no zeros for this quadratic here. That means this quadratic never crosses the x-axis, which means there are no spots where this particle turns around. The velocity is either always positive or always negative. So to do sign analysis, I can pick any number, plug it in, and see what I get. So I'll plug in 0. Velocity of 0 is 8, which is a positive number. So I know that this velocity is always positive because at 0 it's positive and it never crosses the x-axis. There are no zeros. So again, if you graph this on your calculator, you could go that route as well. You can see the parabola is always above the x-axis. So since velocity is always positive, so let me start writing some of this. So I'll say that the velocity is always positive for all values. I should mention the interval. On the interval, so the particle is moving to the right on the entire interval. So it's always going right. There is no change of direction. That means net distance equals total distance. So I'll say thus the total distance is the same as the net distance I'll say that's 58.75 centimeters. All right, let's look at another one. The position of a particle is given by this function where it's measured in feet. Find the net and total distance of the particle on the interval 0.5 to 1.5. So again, this is probably going to be a calculator type question. So we'll kind of do a little bit of both here. I'll talk about what you would do without the calculator, but you could also just look at the derivative on the calculator. So the net distance, let's start with that, is going to be equal to the position at the start of the interval minus the position at the end of the interval, and it's the absolute value of that. So you do that out on your calculator, you're getting about approximately rounded. Remember, we're always rounding to 3 decimal places. So now we want to find total distance. So first, we got to find out if this particle even turns around on that interval. So v of t, that derivative is going to be e to the 2t times 2 minus 8. So that's going to be 2e to the 2t minus 8. We want to set that equal to 0. Again, you could graph this on your calculator, graph 0 and y2, and see, find any points of intersection. But let's see if we can work it out without a calculator. So I add 8 to both sides, divide by 2. So then I'm going to natural log both sides, divide by 2. So it is going to cross the x-axis. I don't know if that number's on that interval because I don't particularly know what the ln of 4 divided by 2 is. So this is definitely a calculator active question. So you can figure out what that number is. It looks like it's going to be about 0.693. So that's where it changes direction. So now the way we find total distance is we do the absolute value of the position when it started till when the position to when it turns around and changes direction, plus that spot where it changed direction to where it ends, because it only changes direction once, because there's only one 0 for the derivative where it switches. So then when I calculate that number out, you should get 9.894 feet. That's the total distance. So what we want to say here is if it's a calculator active question, once you get to this, you're going to graph that derivative, and you're going to calculate, you're going to look for a spot where that velocity changes from positive to negative or negative to positive, where it crosses the x-axis. Locate that x, and that is the spot in time in the interval where it changes direction, which seems to happen kind of right away because the interval starts at 0.5 minutes and it changes direction at almost 0.7. So it kind of goes a little bit in one direction and turns around right away and goes the other way. All right, is this our last one? Yeah, our last example. Because then what is that? Okay, practice free response. So let's look at this last one. The position of a particle is given by this function, measured in feet. Find the net and total distance from pi over 6 to 5 pi over 4. So this one's definitely going to be a calculator one. And what we're going to do here is net distance first. The position of where it started minus the position of where it ends. And that's going to be 0.989 feet. Total distance is going to be, we have to find out where it turns around. So we got to start with our derivative. So let's take our derivative by hand. We get 1 plus 2 cosine of t. Just good practice to do some derivatives. Want to find when that equals 0. So I'm going to try to work through it without a calculator. Let me see. Subtract 1, divide by 2. So the cosine where the angle for which the cosine is negative 1/2. Cosine of a half would be the shorter one. That's the 60, but it's on the other side. So it's going to be at 120. In radians, that's going to be what, 2 pi over 3. And is that on our interval? It is. So I could do it by hand. It'll be 2 pi over 3. We're just going to use a calculator here because we're going to need calculators to get the decimals anyway. So let's do our total distance now using a calculator. So we got to do the t. I'm going to put my velocity in the calculator. Sorry, I didn't work this one out ahead of time. Give me a second here. I'm going to pause it and do this on the calculator and get the intersection point. Okay, so 2 pi, we found it was 2 pi over 3, which is approximately 2.094. So then our total distance is going to be the position from where it starts minus the position to where it turns around. You can put in either number. I put in the exact, plus the spot where it turned around. It only does once. Minus, the position where it ends, 5 pi over 4. What I want to say is, I paused there for a second because it only turns around once because the interval ends at 5 pi over 4. So the next time it turns around will be outside of that interval. That's the next time we get a 0, right? 2 pi over 3, and then again in quadrant 3, we would get the same cosine value there. So it would happen again, but it's outside the interval. So it only turns around once in the interval. So then when we calculate this out, again, give me a second here. Getting 3.617 feet. I think that's our last one.